In the last few months alone, we've seen a frightening number of volcanoes erupt or show signs that they may soon blow. What started this volcanic stir craziness? Does it mean that the end of the world is nigh? And can scientists tell us why this is happening and whether we have anything to worry about? Here's what we know so far. It all comes down to where most of the planet's volcanoes are located. About 75% of the Earth's active volcanoes are found in the so-called Pacific Ring of Fire. This is an area of about 40,000 kilometers in length that runs from the western coasts of the Americas through Central America and the Caribbean islands, around the edges of Asia and Oceania, and down to Antarctica. But why are so many volcanoes grouped together in this particular region? Well, the Ring of Fire owes its fiery reputation to the fact that two of the Earth's three major tectonic plates, the Pacific Plate and the North American Plate, meet here. These enormous slabs of rock make up the Earth's crust and upper mantle, and they're in constant motion. The Pacific Plate is sliding under the North American Plate along the San Andreas Fault. It's also sliding down into the Earth's hot interior at the so-called Peru-Chile Trench, and that's where things get spicy. That's because when the dense oceanic crust of the Pacific Plate collides with the continental crust of the North American Plate, it gets pushed down into the planet. As it sinks deeper and deeper into the Earth, the intense heat and pressure melt parts of both plates, turning them into magma. This molten rock is less dense than the surrounding solid rock, so it makes its way back up toward the surface, creating mountains as it cools. In fact, this process is what created the Andes mountain range, but the process doesn't stop there. The magma continues to rise until it reaches the Earth's surface, creating volcanoes along the way. Similarly, as the Pacific Plate dives into the Earth along the Peru-Chile Trench, the same process happens and new volcanoes are born. This is the case for the Andes in South America and the volcanoes of the so-called Circum-Pacific Belt, which stretches from Chile through the islands of Oceania and Japan, and then up to eastern Russia and Alaska. There are more than 75% of all volcanoes worldwide, and they're all created by the subduction of the Pacific Plate beneath either the North American, Australian, or Eurasian plate. But not all volcanoes in the Ring of Fire are created this way. For example, the famous Mount Fuji in Japan sits on top of the meeting point of four smaller tectonic plates. When these plates converge at awkward angles, friction builds up and stress accumulates along fault lines. Eventually, the stress becomes too great and the rocks break, releasing energy in the form of earthquakes. The sudden movement of the Earth's crust can create a void in the mantle, allowing magma from deep within the Earth to rapidly rise and solidify into a volcano. This is how Mount Fuji was formed. This type of volcano formation is also responsible for the so-called Ring of Fire in the Bering Sea between eastern Russia and Alaska. This ring of over 50 small but potentially active volcanoes is thought to be the result of magma that has nowhere else to go after being created by the subduction of the Pacific Plate beneath the North American Plate. But there's no mountain range to build there. So instead the magma erupts onto the sea floor, creating underwater volcanoes. The reason why Mount St. Helens in Washington State and Mount Vesuvius near Naples, Italy, look very different from one another is due to the composition of the magma. Magma that is rich in silica tends to be more viscous or thick, like honey. And that means it doesn't flow very far before it cools and solidifies, creating steep-sided, short-lived volcanoes. On the other hand, magma that is poor in silica is more runny, like water, and flows much farther before cooling. That's how broad, gently sloping volcanoes like Hawaii's Mauna Loa are formed. While many volcanoes in the Pacific Ring of Fire are created by the subduction of the Pacific Plate, others are created by magma that originates deep within the Earth's mantle. This magma is called mantle-derived magma, and it's thought to be generated by the recycling of old oceanic crust that has sunk into the Earth's interior long ago. Unlike the plate tectonics that drive the volcanoes of the Ring of Fire, these mantle-derived volcanoes don't follow the path of the Pacific Plate. For example, the Galapagos Islands, which are made of mantle-derived magma, lie on the eastern edge of the Pacific Plate, hundreds of kilometers from the nearest trench. So now we know what drives the volcanoes of the Ring of Fire. But why are so many of them stirring right now? Scientists don't have a definitive answer yet, but there are some promising leads. One possibility is that we are in for a period of increased volcanic activity that will last for several decades. The last such period occurred between 2000 BCE and 1800 CE. If we are indeed entering a similar period now, that could explain why so many volcanoes seem to be waking up all at once. Another possibility is that the increased volcanic activity is linked to the 2011 Tohoku earthquake and tsunami in Japan. This was the fourth largest earthquake ever recorded, and it released an enormous amount of energy. Some researchers speculate that this energy may have triggered other faults along the Pacific Ring of Fire, leading to increased volcanic activity. However, other scientists argue that the energy released by the Tohoku earthquake was too spread out geographically to have a significant impact on volcanoes over such a wide area. Yet another possibility is that the recent increase in volcanic activity is simply a matter of probability. After all, the Pacific Ring of Fire is home to a large number of volcanoes, many of which have been dormant for centuries. It's only a matter of time before some of them erupt. For example, before it erupted in 2021, Mount Pinatubo in the Philippines had been quiet for more than 300 years. Similarly, before it blew its top in 2018, Mount Kilauea in Hawaii hadn't erupted in almost 400 years. The point is that even random chance would produce a noticeable uptick in volcanic activity every now and then, and perhaps that's all it is. Although the frequency of volcanic eruptions does not appear to be increasing, according to data from the Smithsonian Institution's Global Volcanism Program, the number of volcanoes erupting each year fluctuates naturally. But while scientists work to figure out why so many volcanoes have been erupting lately, it's important to remember that many of them are not actually dangerous to human life. Of the nearly 1,500 potentially active volcanoes in the world, only about 500 have had at least one eruption in the last 10,000 years that could pose a threat to humans. And of those 500 or so volcanoes, only a small fraction are likely to erupt in any given year. For example, according to the United States Geological Survey, or USGS, the probability of Mount St. Helens erupting in any given year is about 1 in 100. On the other hand, the probability of Mount Vesuvius erupting in any given year is about 1 in 10,000, and the probability of a large-scale eruption that would affect much of Europe is about 1 in 27,000. There are plenty of volcanoes in the Pacific Ring of Fire that haven't erupted for thousands of years and are not expected to erupt anytime soon. Take Mount Kenya, for example. The last time it erupted was about 200,000 years ago. Or take Mount Hood in Oregon, USA, which last erupted 1,500 years ago. Even Mount St. Helens, which erupted just 40 years ago, is not expected to erupt again for another 300 years. Of course, it's impossible to predict exactly when a volcano will erupt. And if you live near an active volcano, you should always follow the advice of local officials in the event of an eruption. But for the vast majority of us who live far from dangerous volcanoes, the recent spate of eruptions is nothing to worry about. It's simply a reminder of the awesome power of nature and a testament to the amazing forces that shape our planet. Thank you for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So to all of our patrons, thank you for what you do to make this happen. If you're not a patron, but you want to learn more about what that means, you can go to our support page.